Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. In a previous session, we had started with the fourth chapter of class 12th, which is called as Determinants. And we had seen the introduction to determinants as well as some properties, and we also proved each property with an example. So we'll just have a very quick recap what we saw in the previous class. Okay, we'll move on to the next topic. So that is the continuation of the properties. So in the recap, we had seen property number 1, the value of the determinant remains unchanged if its rows and columns are interchanged. And also property 2, if any two rows or columns of a determinant are interchanged, then the sign of the determinant changed. So these are the properties which we had seen in the previous class. This is just a quick recap. Next, moving on, next one, property 3, if any two rows or columns are identical, all the corresponding elements are same, then the value of the determinant is 0. Okay, we have proved this also. If each element of a row of a determinant is multiplied by a constant k, then its values get multiplied by k. So these are the 4 properties which we had seen in our previous class, and we have also proved each and every property with an example. So in today's class, students, after property 4, we are going to continue again with the properties of determinants, starting with property number 5. So we'll just have a look at this property number 5. We will also prove this property with an example. Alright. So property number 5. If some or all elements of a row or column of a determinant are expressed as sum of 2 or more terms, then the determinant can be expressed as sum of 2 or more determinants. Means, so just see here, if some or all elements of a row or column, so row or column of a determinant are expressed as sum of 2 or more terms. Sum of 2 or more terms means, so this I will be showing you in an example. Then the determinant can be expressed as sum of 2 or more determinants, which means, so for example, let us have a determinant here. So this is one determinant and this determinant is having one value. Alright. Now we are going to apply property number 5 on this. So we will write this is equal to determinant of row 1 and row 3 we will write as it is, students. Okay, 3, 2, 1, and here we'll write 1, minus 4, minus 1. Same here, plus 3, 2, 1, 1, minus 4 and minus 1. Correct? So row 1 is unchanged, row 3 is also unchanged. Now what we are going to do for row 4, the second row is, this is where we are going to apply the property number 5. So here we'll write 3 minus 5, 1. Okay. So 3 minus 5, 1. Here we have 4 minus 7, 3, right? Here we'll write 3 minus 5, 1. So plus 1, so that it will become 4. So here we'll write 1. Minus 2, it will become minus 7, minus 2. And 3, 1 we have already written here, so we'll write here 2. So now just check 3 plus 1, 4. Minus 5, minus 2, minus 7. 1 plus 2, 3. So this is what property 5 is all about. If some or all elements of a row, so we have chosen the row here, and which row we have chosen? We have chosen the second row. So row of a determinant are expressed as sum. We have expressed that as sum, right? So 3 is written as 1 plus 2, minus 7 is written as minus 5 and minus 2. Correct? Sum of terms, then the determinant can be expressed as sum of 2 or more determinants. So that is nothing but the sum of these both determinants will be equal to this determinant. Alright. So let us first solve this determinant. So see what we are getting here. To solve the determinant, again we have to write the cofactors plus, minus and plus. So we'll write plus 3 of 7 plus 12. Correct? Minus into minus is plus. Minus into minus is plus again. So 7 plus 12. Minus 2 of minus 4 minus 3. And finally plus 1 of minus 16 plus 7. Correct? So plus minus plus. Plus 3 of 7 plus 12, minus 2 of minus 4 minus 3, and plus 1 of minus 16. So that is minus 16 and plus 7. Alright. So this is what we did. We explained the determinant along the first row. Now let us see what is the value of this. So this again can be written as 12 plus 7 is 9, correct? 9 into 3 is 57. So write 57. Next, minus 2 of minus 7. So minus 7 into minus 2 is plus 14. So this will become plus 1 of minus 16 plus 7. So what is minus 16 plus 7? Minus 16 plus 7 is minus 9. So plus 1 of minus 9. Is that correct? Minus 16 plus 7. So minus 16 plus 7 is minus 9. So here we'll write again 57 plus 14 minus 9. So 14 minus 9 is 5. So 57 plus 5 is equal to 62. So just before we proceed with these both sum of determinants, okay, we'll just cross check this once, checking whether this answer is right or not. So sometimes what happens, students, there will be some mistakes during multiplication or with the signs and all. So just be careful with the determinants. You have to cross check 2 times at least, or else there might be some mistake. So cross checking it again. So plus 3 as it is, minus 7 into minus 1 is plus 7, minus sign in between, minus 4 into 3 is minus 12, minus into minus will become plus. Minus 2 as it is, so minus 1 into 4 is minus 4, minus sign in between, 1 into 3 is 3. Moving on with the next one, plus 1 of minus 16, so 4 into 4 minus 16, minus sign in between, 1 into minus 7 is plus 7. So I think this will be the right answer. 62 is the right answer. So what is 62? 62 is the value of this determinant. 62 is the value of this determinant. Now what we'll do, we will find out the value of this determinant and also this determinant. When we add these both determinants, we have to get 62 as our answer. So this is what property 5 is all about. Alright, so let's find out the determinant of this. So here we'll write plus, minus and plus. So plus 3 of 5 plus 4, minus 2 of minus 3 minus 1, and plus 1 of minus 12 plus 5. Okay, we'll write the determinant, expand the determinant along the first row here also, plus, minus and plus. So here we'll write plus 3 of 2 plus 8, minus 2 of minus 1 minus 2, and plus 1 of minus 4 plus 2. Find out the values of this. So 3 into 9 is 27. Minus into minus will become plus. 2 into minus 4. 2 into minus 4. Minus 2 into minus 4 is plus 8. Plus 1 as it is. Minus 12 plus 5 is minus 7. So here we are getting minus 7. Same thing here. 8 into 2. 8 plus 2 is 10. 10 into 3 is 30. Minus into minus will become plus. 3 2s are 6. Minus 4 plus 2. Minus 4 plus 2 will give us minus 2. Minus 2 into 1 is minus 2 as it is. What is the value of this determinant now? Minus 7 plus 27, this is becoming 20. 20 plus 8 is 28. Plus, this is that plus sign. 30 plus 6 is 36. 36 minus 2. 36 minus 2 is 34. Now 28 plus 34. How much will be the answer? 58, 62 will be the answer. So which is equal to 62. And this is also equal to 62. So this is property 5, students, which means whenever a determinant is given, okay, any row or any column, if it is expressed as sum of 2 or more elements, then the determinant also can be expressed as sum of 2 or more determinants. And we have proved that. So this is property number 5, proof of property number 5. Moving on to the next property, property number 6. So again, properties of determinant, property number 6. We will prove this property also with an example. Alright. So if to each element of any row or column of a determinant, the equimultiples of corresponding elements of other row. Okay. Equimultiples means, so this, make a note, equimultiples of corresponding elements of other row or column are added, then the value of the determinant remains the same. Value of the determinant remains the same. That is, the value of the determinant remains same if we apply the operation So once we apply the operations like this, okay, the value of the determinant remains same. So for example, in our previous slide, okay, what we had seen is the value of this determinant is equal to how much? 62, correct? The value of this determinant is equal to 62. Now the same thing they are telling. So for the previous determinant, okay, determinant delta will be equal to 62 we got. Now for the same delta, you do one operation, either row or column. So let us choose row here. So let us do like this. R2 equals R2 plus R1. What is K here, students? What is K? K here is 1. So in this place you can put K belongs to any positive integers, correct? So equi-multiples. So that is nothing but here we are using 1, right? So you can put any other positive integer. You'll be getting the same answer. Means the value of the determinant remains unchanged. So we'll see one example. You will understand this property very well. So moving on to the example next. So here if you see, what is the value of this determinant? The value of this determinant is 62. Okay, we had already solved in property number 5. Same example we are taking. So for here what we'll do, we'll make one small change. Okay, so here we'll make an operation. R2 equals R2 plus R1. So do this operation. Now R1 and R3 are same. So write R1 and R3 as it is first. So that will become 3, 2, 1, 1 minus 4 and minus 1. So R2 plus R1, 4 plus 3 is 7. R2 plus R1 minus 7 plus 2 is minus 5. R2 plus R1, 3 plus 1 is 4. What is K here, students? K here is 1. You can also use 2, 3, 4, 5, 6, 7, 8 and so on like that. But this determinant also should give us what value? This determinant also should give us 62. So this is what property 2 is all about. So let us solve this determinant now. We'll write the cofactors plus, minus and plus. So this will become plus 3 of 5 plus 60. Correct? Minus 1 into minus 5 is plus 5. 4 4s are 16. With the minus sign, minus is coming in between default sign in determinants. So it is becoming plus 60. Moving on, minus 2 of minus 7 minus 4. Minus 7 and minus 4. Next, plus 1 of minus 28 plus 5. Okay. Now, see the value of this determinant. 16 plus 5 is 21. 21 into 3 is 63, correct? So this is 63. Minus into minus will become plus. So minus 7 minus 4 is minus 11. Minus 11 into minus 2 is plus 22. So write plus 22. So again minus 28 plus 5. This will become minus 23. So write minus 23. Multiplied with plus 1, it will become minus 23 only. So solve these both first. What will you get? You will get minus 1 and here we have 63. So 63 minus 1 will be equal to 62. So you see this value and see this value. Both the values are same, right? So which means what, students? Which means if the property number 6, read this again. If to each row or column of a determinant, the equi-multiples of corresponding elements of other row. So which other row we used? In R2, we did R2 plus 1 times of R1. Equi-multiples. So each and every element of R1 is multiplied with 1. So that 1 can again be replaced with any other positive integer you want. So if you do these type of operations for a given determinant, the value of the determinant remains unchanged. So we have also proved that with the help of this example. Okay. Moving on to the next question. So moving on to the next property, property number 7. If all the elements of a determinant above or below the main diagonal. So students, what is main diagonal here? So there is one word here, right? Main diagonal. So this main diagonal is nothing but principal diagonal. Okay. So that is called as main diagonal. Consists of 0, then the determinant is equal to the product of diagonal elements. So see here. Then the determinant is equal to the product of diagonal elements. That is, so you can see one small example here. So we have taken one determinant. Okay, we have taken one determinant. And here the elements below the principal diagonal. The elements below the principal diagonal are 0. Here you see the elements above the principal diagonal are 0. Correct? So this is principal diagonal. This is also principal diagonal. Elements below are 0, elements above are 0 here. So the value of this type of determinants will be equal to what? The value of this type of determinant will be equal to the sum of the the product of the principal diagonal. So what is the product of principal diagonal? A1, B2 and C3. So this will be the value of that particular determinant. Moving on. So we will take one small example, prove this, see whether this is right or false, right or wrong, and that concludes with property number 7. So we'll take one small example, students, for property number 7. So for property number 7, we'll take determinant of, let us take -3, -1, 4. Okay, -3, -1 and 4. Here we'll write 0, 0, 0. And again here we'll write some other numbers. Let us take 8, 9 and 10. Okay, 8, 9 and 10. We'll find out the value of this determinant now. So before we start with the value of the determinant, we have to write the cofactors plus, minus and plus. So plus into -3, so that will become -3 of 4 into -1 is -4. 0 into 10 is -0. Correct? Next, -8 of 4 into 0 is 0, -0. Plus 9 of 0 into 0 is 0, -0 again. So this is becoming 0, correct? Because 8 into 0 is 0, 9 into 0 is also equal to 0. What do we have now? We have -3 into -4. So -3 into -4 is +12. Correct? -3 into -4 is +12. Now this is the value of the given determinant. What we had seen, product of the diagonals. So what is the product of the diagonals? 3 into -1 into 4. So -3 into -1 is +3. +3 into 4 is equal to 12. So see this, +12 and +12. So this is our what? 7th property, students. So there are totally 6 properties in your CBSE textbook. One property I have taught you extra. So this is very easy property, right? So this is called as main diagonal or principal diagonal, and the elements below it, if they are 0, then the value of the determinant will be equal to the product of the diagonals. So this is our property number 7. So once again revising from the very beginning, property 1 to property 7. So property 1, the value of the determinant remains unchanged if its rows and columns are interchanged. So this we have already proved. So for example, A, B, C, D, E, F, G, H, I is equal to 10 if you assume, just an assumption. Then change the rows and columns, A, B, C, D, E, F, G, H, I. This will also be equal to how much, students? This will also be equal to 10. If any two rows or columns are interchanged, so interchanged means what? So now this is equal to 10, right? So now G, H, I, A, B, C, D, E, F. Then this will be equal to how much? -10. Okay, moving on to the next one. So property 1 and property 2. Next, property 3, if any two rows of a determinant are identical, all the corresponding elements are same, then the value of the determinant is 0. So students, there is one small addition here. So in the textbook it is given as it is, identical, or you can also add identical or proportional. So what is the meaning of proportional? Give an example for identical as well as one for proportional. Identical means what, students? Means both the elements are same with the same numbers and same sign. So for example, like this. Okay, 1, 1, -1, 1, 1, -1. So here we'll write 3, 9, 12. See these both rows, row 1 and row 3, same numbers and same sign. So +1, +1, +1, +1, -1 and -1. So they are identical, right? What will be the value of this determinant? 0. Now what is the meaning of this proportional? Same example we'll take. Okay, 1, 1, -1, 3, 9, 12. Here we'll write 4, 4, -4. Now see this, row 3 and row 1. So 4, 4, -4, 1, 1, -1 we have. Are they proportional? Proportional up to which number? Into 4, right? So row 3 is actually multiplied with 4 and we got row 1. So can we write it like this? R1 is equal to 4 times of R3. So this is called as proportionality. So what property 3 is telling us, if any two rows or columns of a determinant are identical or proportional, then the value of that determinant will be equal to 0. And we have also proved this property with an example. Moving on, next one, property number 4. If each element of a row of a determinant is multiplied by a constant k. So we'll take the previous example only. So we have taken A, B, C, D, E, F, G, H, I, and we assume the value of this determinant is 10. Now what we'll do, we will multiply into minus 3 to second row. So what will happen? First and third will be as it is, A, B, C, this will become G, H, I. So minus 3 into R2, so that will become minus 3D, minus 3E, minus 3F. Correct. So read that, if each element of a row or a column of a determinant is multiplied with a constant k. What is the constant we have taken here? Minus 3. Then its value, what is the value of this determinant? See here, 10. Then its value gets multiplied by k. So here we can write 10 into, what is the constant we had multiplied? Minus 3. So 10 into minus 3 is equal to minus 30. So this is what, students, property number 4. So 1, 2, 3, 4 we had already seen in the previous class. This is just a revision. Moving on to the next one, property 5. So property 5, directly we'll see the example, we'll understand it better. So if a determinant is given like this, any row or column, if you express that as a sum of 2 or more elements, then that will be equal to the sum of 2 or more determinants. So for example, the value is 62 here. So these both values, if you add, you must be getting 62, and we are getting it. So this is property number 5. Moving on to the next one, property number 6. So for any row or column, if you operate that particular row or column with the equimultiples of other row, then the value of the determinant remains unchanged. So again, we'll see an example here. So again, so this will be better. So this is the original determinant. We got 62 as our answer. So for this original determinant, what we will do is, we will multiply R2 is equal to R2 plus 1 times of R1. Any other number also can be added here. So you will be getting the same answer. So we'll do one more small example on this side, students. Okay, so this time we will take another row, another equimultiple. We'll see whether we are getting the right answer or not. Just an example. Okay, so what we had here, 3, 2, 1. So 3, 2, 1, 4 minus 7 and 3, and we have 1 minus 4 and minus 1. Okay, so writing the cofactors, we'll write plus, minus and plus. So here we'll write plus 3 of 7. So we have to actually operate first. So here we did R2 is equal to R2 plus R1, right? So this time we will take R1 is equal to R1 plus 3 times of R3. R1 plus 3 times of R3. So that will give us how much? 3 times of R3. 3 into 1, 3. 3 plus 3 is 6. 3 into minus 4, minus 12. Minus 12 plus 2, minus 10. Correct? 3 into minus 1, minus 3. Minus 3 plus 1, minus 2. R2 and R3 as it is, 4 minus 7 and 3. Here we have 1 minus 4 and minus 1. So we'll find out the determinant, value of that determinant. We'll write down the cofactors here, plus, minus and plus. So we'll start with this, plus 6 of 7 plus 12, correct? Minus into minus is plus, minus 12, in between we're getting a minus sign, so it will become plus 12. So minus into minus again, so that will become plus 10. 3, 4, 3, so yeah, plus 10. Plus 10 into minus 4 and minus 3. Minus 4 and minus 3. Next, plus into minus will become minus. So we'll write 2 there. So this is becoming minus 16 plus 7. So let's solve this now. What we'll be getting? 19 into 6 plus 10 into minus 7. 10 into minus 7 is how much? Minus 70. Plus into minus is again minus. So we'll write minus 70. And minus, so this is becoming 16 plus 7, right? So 16 plus 7 will be equal to minus 9. Minus 9 into minus 2 is plus 18. So check the value of this now. 19 into 6. 19 into 6, 9 6 are 54. 6 1s are 6 plus 5, 11. Correct. 19 6 is 114. So 114 minus 70. 114 minus 70, 30, 44 we are getting. 44 plus 18. So 44 plus 18. So this is becoming 12, 4, 5 and 6. 62 again. We are getting the right answer. Which means, so here we had used R2 is equal to R2 plus 1 R1. And here what we have used? Here we have used R1 is equal to R1 plus 3 times of R3. Equi-multiples of another row. And still we are getting the same answer. Are you getting this? So this is property number 6. Another example we have seen. Moving on to the last slide. Property number 7. If all the elements of the determinant above or below the main diagonal, so what is main diagonal here? That is nothing but the principal diagonal, consists of zeros, then the determinant is equal to the product of diagonal elements. So the determinant is equal to the product of diagonal elements. So that is nothing but demonstrated like this. So this is the determinant. Below the principal diagonal all the elements are 0. Above the principal diagonals all the elements are 0. Then the value of this determinant will be the product of the principal diagonal A1, B2 and C3. So for this also we had seen one example. So this is that example, and the product of determinants is equal to 12, and when we solve this determinant also we are getting the answer as 12. So this is the end of the properties of determinants. So students, by using the properties of these determinants, you will be getting a 4-marker question in your examination and at least 1 mark in your competitive exam like KCET or IIT JEE. So determinants has a pretty decent weightage in the competitive examination as well as in your PUE examinations. So we are going to stop the slide here now. I'll be seeing you in the next class with the next chapter, with the next topic in determinants. So until then, take care and subscribe to Vista's Learning. Thank you.